So now we've moved on from single step equations, and you're saying to yourself, this is going to be sketchy. We have to do more than one thing. I can't follow the exact same procedure every time. Don't stress. We have this nice little thing. I like to call it SADMEP. So what is SADMEP? Notice how I'm writing the colors here. Well, what is SADMEP? Look what this is the other direction, okay? PEMDAS, right? This going this way. SADMEP the other way. SADMEP the other way. Well, SADMEP is just a nice way to remember what order to do stuff in. Okay, so, and you might be asking yourself, well, how do I distinguish? You know, we always use PEMDAS. Well, PEMDAS. Why do we need to change now to this other thing to solve equations? Well, the idea here is that think about what you're doing to this equation. You're actually applying inverse operations. I keep saying this over and over, right? We're applying the inverse operation. Well, we're doing the inverse operations of things in order to get back to an original, x or unknown. So let's try one and talk about it as we go. So that's kind of the reason why we do. Okay, so I know I have to do addition then multiplication. Why is that? Because you're applying inverse operations, so it only makes sense that you do the order of operations backwards, right? All right, so here's one. We can try this one out here. 9m plus 27 equals, let's say, 13. Negative 13, why not? Throw a negative in there. All right, so what do we do first? Well, we ask ourselves again, what is happening? Right? This is what I always want you to do. Ask yourself, what's happening to our variable m? What is happening to it? Well, we have a 27 being added, right? Two things, right? 27 being added to our variable and a 9 being multiplied to our variable, right? So now we say, okay, what do I do? Follow SADMEP. All right, the inverse. Applying inverse operations in the inverse order of operations, right? So for this guy, we're going to start with a 27. So we have a positive 27. Let's apply the inverse, or add. Oh, let me change to green. Add the opposite number, right? Which is the additive inverse. Additive inverse is adding the opposite number. Well, the opposite of positive 27 is negative 27. So if we do that first, and I'll do this vertically this time, those cancel out, right? And we're left with our 9m, right, equals negative 13. Oh, what did I forget to do? The golden rule. There's a minus 27 on both sides because of that additive property of equality, right? And 13 and 27, oh, what is that going to be? Well, okay, well, 3 and 7, that's 10. So that's going to be negative, a negative and a negative, right? Negative, same sign, take the sum, right? So that's 40. So let me get rid of this, 13. I just did it over here. So that's going to be negative 40, right? I think that's right. Check my arithmetic. Anyway, so what's happening now to m? We ask, okay, we got to keep going. M's not by itself. What's happening? It's being multiplied. Let's apply the inverse operation, the multiplicative inverse here, okay? Well, the multiplicative inverse is simply the 9. Let me put this original 9 in our black color, so we know we didn't do that one. 9 times the multiplicative inverse of 1/9, right? And then m, of course, is still there. And now we know, and this is the same 40, negative 40 times. We do this to both sides, right? Times the oops, oh, not negative, times positive 1/9 on both sides. Good. And we now know, right, that these cancel each other. So I won't go through that whole, that whole process. So now we're just left with m. And, well, 1 times m, which is just the same as m. And then we've got, negative 40 over 9. Well, can we simplify this? Ugh, I don't think so. 3 is not going to go into 40. 9's not going to go. 45 would work, but 9's not going to go to 40. So just leave it here. So m equals negative 40 over 9. All right, so on to the next one here. We've got k over 4 plus 7 equals negative 17. So, again, we want to think about sad MEP, poor MEP. What are we going to do first? Well, what's happening to k? What are we doing? We've got a plus 7 is being applied to k, and there's also an over 4 here, right? Or division, or this, remember, the division is multiplying by 1/4, and let's write that out before we even go forward. Let's just change this around so it looks different. Okay, so this is the same, right? You guys agree? If you don't agree, pause this and think to yourself why this is the same. But I'm telling you for sure, this is the same as what is written above, right? But ask yourself why if you're not sure, and then, or come talk to me. But because that's kind of the interesting part here. So we have 1/4 times k is the same as k over 4 plus 7 equals negative 17, right? So again, we're going to apply inverse operations. So we better do PEMDAS backwards, right? So we've got sad MEP with addition subtraction, or subtraction addition, right? Plus 7 here. So we better apply the additive inverse, which is adding a negative 7, right? Because 7 is positive, change to negative. And we know these are going to cancel out here. Then we have, let me rewrite it here. So this is how you guys should also be rewriting as you're going, to make sure you keep everything nice and clean. Because when you have problems that are going to take up, 2 pages, 4 pages, 5 pages for one problem, it's going to get really messy if you don't just rewrite each step. So now we've got a multiplication going on. So let's apply the inverse operation of multiplication, or the multiplicative inverse, multiplying the reciprocal. Let's do this first one in black. 1/4 times the multiplicative reciprocal would be 4 over 1, or times 4, right? And then we've got k, of course, equals negative 17. Hey, guess what I forgot to do? Well, all you guys are going to forget also. Well, no, you guys probably got it better than I do here. Look at that. I was chit-chatting to myself, and I forgot to do the additive property of equality. So negative 17 and a negative 7. Okay, let's put those guys together, and we're going to end up getting negative and negative, same sign, take the sum, right? 17 and 7, what is that? That's 24, right? Negative 24? I think that's right. Just double check me, of course. You know how my arithmetic can get. Okay, so we got a negative 24 here, right? Okay, and then apply the inverse operation, a multiplicative inverse. Those cancel. That was the whole reason why we chose that, right, in the first place. And then we just do the same thing we do to one side, multiplicative property of equality. Okay, and then we're left with k equals, and then this 24, maybe you can do it in your head. I can't. I'm slow. I like to go slowly. 4 times 4 is 16. 4 times 2 is 8, 9, 96. But it was negative, so it's a negative 96. And that's our answer here, negative 96. So let's go on to the next one. Alright, here we got some fractions, so be careful. Don't get freaked out, just take it one step at a time. Again, we have some addition happening to x. What's happening to x? We asked ourselves, what's happening to x? Okay, addition's happening to x by how much? By 1/2. Also, what else is happening to x? Okay, we've got a 2/3, negative 2/3. That's going to just look messy, but I'll rewrite it. Negative 2/3 times x, right? So we've got addition and we've got multiplication. So following our inverse order, we have to do sad MEP and then apply the additive inverse first, right? 1/2 negative. So adding a negative 1/2, right? And I'll do that to both sides this time. I won't forget. Okay, so those will cancel. We can see those. Now here's the part. You better use some scratch work or use an extra sheet of paper or something. We've got 3. We've got to get a common denominator here, right? Minus 1/2. Or plus a negative 1/2. It's the same. It's totally equivalent, right? Okay, so now I better multiply times 2 to the top and bottom on this guy. So I've got 6 over 2 plus a negative 1 over 2. So that equals to, what is that? That's 5. Positive 5. Yeah, difference sign. Take the difference, right? 5 over 2. So that's positive 5 over 2. Okay, so I'm going to write that in here. So this is 5 over 2. That's this stuff. Working with fractions, don't, just take it slowly. Take your time on it. All right, and we have a negative 2/3 x here still, right? All right, so now we're just left with one-step equations. We already did. Multiply the reciprocal, the multiplicative inverse, right? What about that negative sign? That negative sign stays there. We still use the negative sign in multiplicative inverse, right? Reciprocal negative sign remains. Okay, we don't change, we don't do the opposite number because that would be the additive inverse. We just take the reciprocal. Okay, and we want the multiplicative inverse. So we've got negative 3 over 2 on this side as well. I like to put negative fractions in parentheses, or negative anything is in parentheses when I can. And then these are going to cancel, right? You can see cross cancel. The negatives cancel, the 3's cancel, the 2's cancel, and we're left with, hopefully this will fit on my video here, x, and then just multiply, remember, straight across with 2 fingers, right? 5 times negative 3 is negative 15 over 2 times 2, that's 4, and we cannot simplify. We're done.